who here in the audience uses credit card? This is good because the next lecture is going to be from Mastercard, company that everybody knows, I think. And we're going to talk, in this lecture, we're going to talk about implementing responsible AI at scale. And it's very important because we have so many difficulties I would say this, like scary things also in the AI industry. And for this, I want to invite to the stage Mrs. Adeline Pelletier, right?
Yeah, correct.
Perfect.
Thanks. Hi, everyone. Great to be here. So my name is Adeline. I'm part of the data strategy and AI governance team at Mastercard, which is part of the Chief Data Office. And I'm going to talk to you today about implementing responsible AI at scale. I'm aware it's the last presentation for this morning. I'm the only thing between you and your lunch. I'll keep it sweet, short, and hopefully interesting for you. Great. So as you can imagine, at Mastercard, we have over 2 decades of experience building and deploying AI. And we set ourselves a set of robust principles when we work with our data, which is a key asset. And so we've got a set of data and technology responsibility principles, which are around security and privacy, transparency, accountability, fairness, inclusion, innovation, and social impact. And these are really the principles that will be our North Star, or basically our guide in the way we use our data and we build and deploy our AI model. And so, as you know, while there's a lot of great things we can do with AI, as the last speakers have shown us, there's also important risk that we need to consider, especially an organization like Mastercard. And so, I'm just going to speak. So, some of the risks can include the generation of misleading information or lack of transparency for the end users that might be affected by an AI, amplification of biases that can be present in the data we use to train our models, and also, more generally speaking, concerns around intellectual property, privacy, and data security. And so that's the reason why we really have to define clear accountabilities and responsible implementation strategies. And so Mastercard set up the AI governance program in 2019 to basically respond and tackle these challenges. And the way we've operationalized the principles that I mentioned before was that we create responsible AI through risk identification and mitigation. So early on, when the data science teams come to us with an idea for a project, we work with them to try and identify the potential AI risk. And then we map this risk into mitigation requirements for the engineer, for the data science teams. And we also try and support them by building tools to help them implement responsible AI practices and implement also metrics, in particular, metrics to assess fairness. And we do all that really in close collaboration with, as I mentioned, the data scientists, but also product owner, and also we work very closely with our privacy and legal teams. So I'll dive deeper into what the AI governance program does. So we focus on 3 pillars when we assess the projects that come to us. We look at efficacy, so we try and assess whether the solution will meet business expectations. We look at fairness, so we assess whether there's a risk that this AI might treat different populations differently and lead to discrimination. And we assess transparency. So we want to ensure that the solution is actually well explained to customers or the impacted end users. And so you see here at the bottom on this graph, it's basically the AI life cycle, development life cycle. And so we split it in three parts for the purpose of AI governance. So risk assessment. So as I mentioned, when the teams come to us with an idea for an AI solution, then we've got a scorecard that helps us assess the level of risk in this model. So thinking in terms of what data they use, how the data is going to be used in the training for the model, and also what is the potential impact on the populations. And then after they've built the model, we move into risk measurement, and we've built tools like the bias testing API, which I'll discuss more in a minute. And then once they deploy, then we've also helped them with tools around monitoring their model once it's in production. What I'll focus on in this presentation is how we've worked with these teams to tackle bias at scale. And really, I think one of the key challenges that we have is when we implement AI governance, we really think about the fact that, so the AI governance team is actually quite small, but we assess any AI models that is built at Mastercard or any AI model that we buy. So we really need to think about how we can do that efficiently, both for us, but also for the data science teams. And so here again, when we talk about bias, here we're really talking about bias in the fairness sense. So, a result or outcome of an AI that could be unfair or unjustified or discriminatory or contrary to applicable law. And so these bias assessments are really an important part of implementing our data responsibility principles, which I mentioned earlier. And so we identify and remove bias in our AI models to reduce regulatory risk, revenue, reputational risk. And these bias assessments are required at Mastercard when an AI product or solution is likely to impact an individual or a population. So before I go into some of the solutions that we've implemented, I just want to mention that there are many challenges to bias test model at scale. And that's, I think, really not only for Mastercard, but really across the industry. One of the first challenges is that what it means for a model to be fair will really depend on the context. So if you think about a marketing context, like a recommender system, we would anticipate that there's some correlation between the recommendation and, let's say, the gender of the person. But if you think about a lending context, we would want the decision to make a loan to be independent of the gender of the individual. Right, so that's the first challenge, really trying to understand what's the right fairness concept for a specific model, for a specific context. The other, I think, key challenge is that there's no standards or industry alignment in terms of how which metrics we should employ, and what's the broad fairness for bias assessment. And finally, I think another key challenge is the lack of access to demographic data. And I think that's really a challenge across the board, in the sense that if you want to assess whether your model will perform differently across population, you need to have this demographic data. You need to be able to match it to your model scores or your training data. And it's actually quite hard to get this demographic information. This is a presentation of the broad framework that we use for this bias assessment. So as I mentioned, we start from a real understanding of what is the context and what is the fairness metrics that should be applied. Then we identify the demographic data that we should be using for this exercise. And then we look at the presence of bias first in the input data, because a lot of the time the bias is basically coming from the data that you use for training the model, so historical biases. And then we test for bias in the output data in the model scores. And then if we identify that there is bias, then we try and mitigate this, in particular by using pre-processing methods, so trying to remove the bias in the input data. And in terms of tooling, so we've worked with data scientist teams to develop a bias testing API, which basically allows for efficient bias testing at scale. So before we had this API, what used to happen is that each data science team was coming up with their methodology to assess bias, and then it was very time consuming. There was also a logistics part of matching the demographic data to the input and output. And so with this API, it basically considerably reduced the turnaround time from it used to take around 6 weeks, now it takes 1 day. And that allows us to have standardized metric calculation. And it also outputs a nice report, which is easy for AIGov to basically review. So I'm conscious of the time. So another thing that I want to quickly mention in terms of the efforts we've made towards tackling bias at scale is we've started to work with external research institutions, and in particular the Alan Turing Institute in the UK. So we worked with them in what they call a data study group, which is basically a week-long hackathon. And they put together a team of 11 researchers. We have a background in fairness, in computer science, in data science. And they helped us define a methodology to assess bias in multi-label classification and multi-label regression models. And we focused on this one because there was no standard methodology for that. And so now we're planning to use this research and implement it as part of our tooling. And just the last few words, in terms of future work that we're starting to look at. So we're working on extending this AI toolkit to include measures of bias and efficacy for Gen AI. So again, partnering with our data science team to work on metrics to evaluate LLMs, in particular for chatbot use case. And last quick thing, so we're also looking into using synthetic data for AI fairness. Exploring ways to leverage synthetic data to enhance privacy and then remove or mitigate input data bias. Thanks, everyone.
Thank you so much. Questions from the audience, please. Yes, here.
Two quick questions. One, can you give example about the explainability, what you need to explain and how you do that? And the second one is, I come from the fintech industry, and in our not in Israel, and in our area, gender, for example, is an indicator about how reliable you are. Women pay back loans better than men. So this is a fact. So how do you deal with this in bias? I mean,
there might be some correlation between this demographic data and the features. Even if you remove it, it will still pop up. But we basically just don't use that as features. So does it mean that the model might not be as efficient or performant as a model that would include this demographic data? Yes, it's possible. But just again, going back to the data principles, it's something that might lead to bias. So we're just
okay. And what about explainability?
So explainability, so this is something that we're starting to look at. I think the way we look at it is there's two layers. One is more around how do you explain the models in kind of high-level terms to the customers or to the end users, obviously. And the other one, we at the moment, the teams are using fairly simple methods like SHAP to try and explain their models.
Okay, thank you.
Last question.
Thank you. You mentioned a bias testing API which you have developed for the company. I'm just curious to understand what is the input and output of this API which you've developed?
Yeah, so basically, we work with the data science teams to develop a script that will basically develop a methodology to really assess bias. So in terms of the output, you basically get a set of metrics, so both on the input data, so trying to basically look at whether there are associations between specific sets of demographics and the input, the features of the model. So we look at, the top 10 features. We look also at the general distribution, of the data, demographic distribution of the data, and the outputs basically. So looking at model scores and whether we see specific differences across the different demographics. So for marketing model, typically we would consider that what matters in terms of the bias is ensuring that there's no significant differences in performance across group, because actually we do expect there's going to be some kind of allocation differences, because as I mentioned, the recommender system will recommend different things to men and women, and we're fine with that because it's by design, right? But so depending on the domain, we would have different metrics. So, standard things like looking at equality of opportunity or equalized odds. And so this bias testing API would output a report, and the moment it's basically a simple Excel spreadsheet with all these different data that then the AI governance team leverage to write a report and look at the bias in the model.
Right, thank you. Thank you so much, Adeline. And I want to thank all the speakers we got here. I hope you learned some new things. I had so much fun time with you. I hope you also as well. Now we have, you won't believe, lunch. We have lunch, and we're gonna meet here in 1:30 p.m. for the signal processing track. We're welcome to come back. See you next time. Bye bye.